We've talked about already what I've called and what textbook writers tend to call intersect. Intersect. Okay? Intercept, intersect, they look the same, just a one-letter difference. They actually mean pretty much the same thing, but we tend to use intersection to talk about when two lines cross each other. When two lines cross each other, they intersect. Intercept also talks about things crossing paths, but in mathematics, we tend to use it for one very specific case, and that would be when a line is crossing an axis. So this down here, where this blue line is crossing the x-axis, would be called an x-intercept. All right, x-intercept, where a line crosses an axis. In this particular case, the x-intercept is -6, 0. Okay? If I asked about the x-intercept of the purple line, we'd be talking about over here. Where does the purple line cross the x-axis? And that would be at 8, 0. All right, x-intercept. Y-intercept then would be where does a line cross the y-axis? Okay, the y-intercept, where does the line cross the y-axis? Sometimes intercepts are easy to find, like these three, -6, 0, 8, 0. This would be 0, 4. Actually, probably 0, 3.5, because it's between 3 and 4. Okay, that would be a y-intercept. Sometimes intercepts are more difficult to find. This blue line is going to cross the y-axis, but it's going to cross up here somewhere. So I would have to use a different strategy than just using my eyes to figure out where is it crossing. Okay? We're going to look at intercepts, though, in a bunch of different contexts. So the first context, the place that it gets its definition from, is graphing, which you just saw. Another context that we can talk about intercepts in is the context of equations. And if you think back to graphing, when I'm crossing the x-axis, okay, so when I have an x-intercept, my y value is 0. All right, so for x-intercepts, y equals 0. X has a value, y equals 0. The reverse is true for y-intercepts. When my line is crossing the y-axis, x equals 0. Okay, so we can use that information to find x and y intercepts for equations. Take this equation, for example. If I want to find the x-intercept, y is 0, so I'll have 13x's minus 0 equals 78. And I don't even really need to write that term at all. 13x's equals 78. You know how to solve for x. The x-intercept is going to be 6. All right, divide both sides by 13. X equals 6. All right. If, on the other hand, I want to find the y-intercept, take this equation and make x be 0. Okay. So -3 times y is 78, and you can figure out what y is. Divide both sides by -3. Y equals -26 when x is 0. All right? So my two intercepts for this equation are 6 is 0, all right, x equals 6 when y is 0, and 0, negative 26. Y equals negative 26 when x is 0. Find my x-intercept over here. X will have a value. Y will have no value. Y will have a value of 0. So 0 minus 4, negative 4 equals 2 times my x-intercept minus 5. Do a little math. All right, you should be able to solve for x at this point. This is like skill number 10 or skill number 24. Divide both sides by 2. We'll have negative 2 equals x minus 5. Add 5 to both sides. We'll have 3 equals x. Okay? When x is 3, y is 0. When y is 0, x is 3. That's my x-intercept. Same idea. If I want to get my y-intercept, for my y-intercept, x will be 0. So 2 times 0 minus negative 5 is negative 5. 2 times negative 5 is negative 10. Y minus 4 is negative 10. Y must be negative 6. So my y-intercept is negative 6, or 0, negative 6. X is 0, y is negative 6. Okay, so that's finding intercepts from an equation. Another context that you might be asked to find an intercept in is tables. All right, tables of values. And this is what you're going to want to do if you have to find an intercept given a table. If I want to find the y-intercept, I know that x needs to be 0. Okay? 0 is going to be somewhere in here between negative 3 and 8. And I need to find out when x is 0, what is y. So there's a couple different things that you can do with this. Number one, you could graph all of these points. Okay? Negative 3, negative 7, 8, 26, way up there, 15, 47, way up. Okay? I'm going to have a really big graph to graph the points. But you could graph the points and then look for, on your graph, where are the intercepts. A different thing that you could do is use the table to write an equation. And if you remember from skill number 29, point slope form, we can find the distance. Actually, let me use positive numbers. Find the distance from 8 to 15, that's plus 7. The distance from 26 to 47, that's plus 21. Slope is change of y divided by change of x, 21 over 7. 3 is my slope. Okay, and now I could write an equation. Y minus a y value, let's say 8. No, that's an x value. Y minus 26 equals slope 3 times x minus 8. All right, using this point, 826. And if you wrote an equation, then you could do what we just did, right? You could fill in 0 for x to find your y-intercept, fill in 0 for y to find your x-intercept, okay? That is a way that I would love you to do because it would let you practice so many of your other skills. However, if you don't want to go that far, we can stop right at where we find slope. Slope is 3. That lets me know that every 1 that I go up in x, I'll go up 3 in y, so I can start just counting within my table. I'm going to write this again. Negative 3, negative 7. Let me count up. 1, 2, 3, 4, 5. Okay. Since my slope is 3, when I move up 1 in x, I move up 3 in y. So we'll be at -4 there. All right. Plus 1 here is plus 3 in y. Plus 1 here, plus 3 in y. Okay? And I will arrive just by counting at 0, 2. So 0, 2 would be my y-intercept. All right. Now, my x-intercept, you do the same kind of thing. It's going to be a little harder because it's going to end up being a decimal. My x-intercept has to be somewhere between 0 and -1 because I need y to equal 0 at my x-intercept. Okay, so I'm going to take this table, I'm going to expand it a little bit more. I don't remember where that number was, -1, right. And I'm going to split up my y's. So we got -1, 0, 1, 2. So I'm taking 3 steps in the y direction. I need to be taking 3 equal steps in the x direction to get from -1 to 0. So I'm basically going to be counting by thirds. -2 thirds, -1 third, 0. Okay? Here is my y. Here is when y is 0, my x-intercept. All right? So again, seems a little tricky, feels a little tricky. Not really that tough. What you're doing is counting. What you're doing is counting through a table. Right? Finding the slope makes it easier to count through the table. But as you could see here, I didn't really use the slope for this one. You can just figure out how far are you counting on one dimension and then split your distance by equal amounts in the other direction. Let's look at another one here. See if it can become more clear. First off, I'm looking for a situation like this. I'm going from negative to positive in y, right? From negative to positive. So I know that 0 is between +1 and -2 to find my x-intercept. Okay? So those are the rows that I'm going to separate. -10, 1, 0, -1, -2. Okay, so I'm counting by ones in my y direction. Right now, from my table, all I know are the end points. -10 goes with 1, -4 goes with -2. And the question is, can I fill in this gap? All right, I'm going to need to make 1, 2, 3 steps, and I need to get from -10 to -4. So I'm traveling up 6. In 3 steps, that means each of my individual steps should be +2. Right? -10 plus 2 is -8. -8 plus 2 is -6. -6 plus 2 is -4. Right? Here is my x-intercept. I don't know what's the x-intercept because the x column has a value. The y column is 0. Same kind of thing. To find my y-intercept, I know that my y-intercept is going to be where x equals 0, and x is going to equal 0 somewhere in here, between -4 and 8, because I'm going from negative to positive. So I can do the same kind of thing, new table, new situation. well, actually, I could just continue out this table, but I'm going to continue it out in a different way. Starting at -4, -2, I'm going to count up by ones in the x column. So -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8, -8 over here. Now I need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I need to make a jump of +12 in the x column at the same time that I'm making a jump of just +6 in the y column from -2 to -8. Or that's not a +6, that's a -6. All right. What size steps am I going to take? If I'm going to make 12 steps and only go down 6, that means that each step is going to be 1/2. All right, half steps. So this would be -2.5, -3, -3.5, -4, -4.5, -5, -5.5, -6, -6.5, -7 goes with that 6, -7.5 goes with that 7, -8. Okay? The thing I'm looking for is this 0, -4. That's my y-intercept. All right, now, this is a lot of writing, a lot of thinking, a lot of working. Okay? Simple thinking because I'm just counting. But, again, I would like it if you could write an equation to go with your table and use that to jump directly to the answers. So you can use either method when you're dealing with a table. If I had to write an equation, I'm doing something like this. +12 -6 slope -6 over 12 -1/2. -1/2. Remember we were counting by 1/2s in the y direction when we were counting by ones in the x direction? Another way to think about that's really you're just using slope in that table when you're counting by increments. Okay, slope is -1/2. Pick a point. Let's use this one, nice and small numbers. Y minus the y value, so minus -2 is +2 equals slope -1/2 times x minus the x value, which is -4, so minus -4 is +4. That's an equation. I could use it again to say, all right, when y is 0, what's x? 2 equals -1/2 x plus 4 times -2 on both sides. -4 equals x plus 4. X equals -8. Right? That's the x-intercept. -8, 0. Find the y-intercept. Make x be 0. We'll have y plus 2 equals -1/2 of 0 plus 4. 0 plus 4 is 4. -1/2 of that is -2. Subtract 2 from both sides. Y equals -4. Okay? That way, I believe, is faster, less writing. Not necessarily easier mentally, but it does let you practice more of the high school level steps that I would want you to practice if you can get by writing these equations. All right, before I move on, let me talk about the situation where you've got a line in a graph. You know because of the arrows that it's going to cross the x-axis somewhere out here. You know it's going across the y-axis somewhere up there, but you can't see exactly where it's going to cross. How do you find the intercepts? How do you find the exact intercepts in that situation? All right. You got two options again. You have a counting option and you have a write an equation option. All right. Write the equation option looks like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 6, 7 is one of my points. 8, 6 is the next point. I should be able to write an equation given 2 points. Or, let's not even say I don't even need the next point yet. I should be able to write an equation if I know 1 point, 6, 7, and I know the slope. So the slope is down 1, forward 2, slope -1/2. All right, you could use that, a point and a slope, to write an equation in point-slope form. Y minus the y value, 7, equals the slope, -1/2 times x minus the x value, 6. All right, point-slope form, not something you need to memorize. Every test that you ever take, including the test you take from me, will have that formula on the formula page, or in my case, on the paper itself when you need to use it. All right, but again, I'm not going to go through finding the x and y intercepts from an equation because we've already done a bunch of those, but you can try. You can hit pause and try to find the x and y intercept using the equation, and then unpause and check against the other method that I use. So the other method is a count method, and basically we go back to the table-like thing, okay? I know that I'm going across this y-axis somewhere. Right now, the closest point that I know to the edge will actually be this point down here, almost at the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. 10, 5 is my point, my farthest point that I know. Okay, now I want y to be 0. So 5, 4, 3, 2, 1, 0. I want y to be 0. Right now I'm at x equals 10. All right, now look at this. For every 1 step I take down, I'm taking 2 steps forward. All right, my slope. For every 1 step I take downward, I'm taking 2 steps forward. So we're marching this down by 1s, but we should march this forward by 2s. Down 1, 4, forward 2, 12. Right? Down 1, 4, forward 2, 12. Down 1, 3, forward 2, 14. Down 1, 2, forward 2, 16. Down 1 to 1, forward 2 to 18. Down 1 to 0, forward 2 to 20. So this line is going to cross the axis at x equals 20. All right, going backwards to get my y-intercept, I'm going to start at 6, 7. I want x to be 0, so 6, 5, 4, 3, 2, 1, 0. For every 2 that I go backwards, I'm going to go up 1. So let me skip some of these. 6, 4, 2, 0. Backwards 2, up 1. Backwards 2, up 1. Backwards 2, up 1. 0, 10 is going to be my y-intercept. Hopefully that's the same thing that you got when you were using the equation if you did hit pause and try. All right, 20, 0, 0, 10. Hit pause, try these. All right, find the x and y-intercept for these two equations. Find the x-intercept and the y-intercept for this table. Name the x and y-intercepts that you can see from the blue squiggle and the pink line, and also see if you can figure out the x-intercept for the pink line that you can't see. It's over here. All right, off the graph. Hit pause, try them. A solution will appear after a while.